Hello and welcome to Congruent Triangles. Today we're going to look at ways that we can prove that two triangles are congruent. To be congruent, they would have to be the exact same size and the exact same shape. Now if all the sides and all the angles were equal, then we could do a series of transformations. We could slide it, flip it, rotate it to match one triangle on top of the other, and that's how we know that they're congruent for sure. We could say if two polygons are congruent, then there is a sequence of rigid transformations that maps one onto the other. And the converse is true. If there's a sequence that maps one onto the other, then they are congruent. But we don't always need to have all the sides and all the angles marked. We can sometimes get away with less. There are 5 ways that we can get away with less. The first is, what if we have all 3 sides? 1, 2, and 3. All 3 sides are equal. That's enough to prove I could twist this thing and put one on top of the other. They have to be the same size and the same shape. And this is called side-side-side congruence theorem. And that's if all 3 pairs of corresponding sides are congruent. Then the triangles have to be congruent. So we don't always need the angles. If we have all 3 sides, that's enough. Here's another one, where what if we have side, side, and an angle that's in between? This is also enough to show that these are congruent, because that angle has to open it up to be the same amount, which means this third connecting side has to be the same length. So we'd have side, 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 which we had here. This one, though, is called side, angle, side, because the angle is in between the 2 sides. If 2 pairs of corresponding sides are congruent and the angles between them are congruent, the triangles are congruent. The third way we can prove is something like this, where we have 2 angles that are the same and a side that's in between. So this would mean this would be angle, side, angle. If 2 pairs of corresponding angles are congruent, then the corresponding sides between them are congruent, then the triangles are congruent. The fourth one here is one where we don't have it inside. We don't have it between. We've got angle, angle, and then a side that's not in between. But this one still works because, let's say we knew these numbers. You know, these numbers and these numbers, we know we could subtract from 180 to figure out this angle here. And these angles have to be the same if the other 2 are the same. So if that's the case, then we've got angle, side, angle, which works. Angle, side, angle. So if we start with just angle, angle, side, that's going to work because we could make it work with angle, side, angle. If 2 pairs of corresponding angles and a pair of corresponding sides, that is not between. That's when it works. That's the only time it works to have something that's not in between. Hypotenuse leg is the other one, and this one is for a special kind of triangle where it's a right triangle 90 degrees. Because those triangles have a specific hypotenuse, and if the hypotenuse is the same and one leg is the same, that's also enough to prove congruence. This is called hypotenuse leg. If the hypotenuse and one leg of one right triangle are congruent, then the triangles are congruent. Now we have to be careful because there is one case that people like to use that doesn't actually work. And that's something like this. Let's say we have a side that's the same, we have an angle that's the same, and we've got a third side. So this side has the length of 2. What if I draw that exact same length on the other triangle, but instead of like this, what if I swing it out a little bit? So I'm going to swing out this length, but keep it the same length as this one. And then I just have to extend this side to make it match. Now I have side, side, angle, but these triangles are not congruent. Side, side, angle does not work. And one of the ways you could remember this is that we could respell this in a little different way and say, we'll just say no to this one. Okay? This does not prove congruence, so don't try to use that as a proof. Have a great day.